Today we are going to study about the adjoint of a matrix. Adjoint of a matrix, that is matrix, suppose let the matrix be A, A11, A12, A13, A21, A22, A23, A31, A32, A33 is the transpose of, adjoint is the transpose of, that is capital A11, capital A12, capital A13, capital A21, capital A22, capital A23, capital A31, capital A32, capital A33. These are the cofactors of the matrix. So this is the, that is a transpose is that transpose. That means we will transpose. I take a small example before I start a difficult one. I take a small example. Suppose find the adjoint of matrix A 2, 3, 1, 4. Okay, adjoint of A will be, that is this and this. This only I left out with 4. That is cofactor, and with 3. I left out with -1 because 3 raised to the that is minus 1 whole raised to the power 1 plus 2, that is negative. Okay. Similarly, for the A21, it will be also negative because minus 1 whole raised to the power 2 plus 1, that is minus, and it will be delete. We will delete 2, 1. And 1/4, 2, 1 and 1/4. Okay, then we are left out with 3, -3. Then the last one with 4, this is A22. That is -1 whole raised to the power 2 plus 2, that is positive. So I delete these two, so I get 2. Now that transpose of that, transpose means I change the rows into column and column into rows. Now it will be 4 minus 3 and -1 and 2. Find the adjoint of the next sum, because it is a little I won't say difficult. It will take time for the concept. That is, find the adjoint of matrix 1, 2, 3, 4. Now all of you can do it. That is again 1. It is 4. Again 2. It will be -3 because again with the 3 we cancel these 2. It will be minus because it is 1 minus 1 raised to the power 1 plus 2, and with 4 we are left out with 1, and that is the transpose of it. We change the rows into columns and columns into rows. Cofactor, these are the cofactors. I have found out the cofactors. We are going to start adjoint of matrices. Now, what is adjoint of matrices? Adjoint of matrices is that is a matrix. It is a given A, that is 1, 2, 3, 4. Okay. Adjoint of this matrix will be the A, that is adjoint of A, of A, that is the transpose, I write A11, capital A11, capital A12, capital A21, capital A22, then that is, it is 2, 2, 2, of the transpose. Transpose capital, what is capital A here? Capital A is the cofactor. Capital A is the cofactor of the elements, each element. How many elements are there? There are 4 elements. So I will find out the adjoint of A here. Adjoint of A here. What is this? This is 1. So we will just eliminate this row and this column. Okay, what is left with us? This is 4. Okay. Now the second element is 1, 2. It is minus 1 whole raised to the power 1, minus 1 whole raised to the power 1 plus 2. That is equal to, it will be a negative 1. That is, it is minus 3. Okay. Then element that the cofactor, that is cofactor of 3 is that I delete that 1, 3 and 3, 4. So I am left out with 2, but it should be minus 2 because this is the element 2 and 1. Minus 1 raised to the power 2 plus 1. That is minus 2. And the last one is that it is the 4. So this will be 1. And we will be transposing this. Transpose, do you understand? Transpose means we will change into column into row, row into column. That is 4 minus 3 minus 2 and 1. This is, we have done. Now, my question is that is plus of 12 here. My question is that verify A into adjoint A is equal to determinant of A into I. I is the unit matrix of order, here it will be of order 2. 2 means unit matrix of order 2 will be 1, 0, 0, 1. Okay. Now here A is here. So I am just finding out the adjoint of the matrix. Okay. That is to adjoint of the matrix. This is, I delete. Element of 2 will be minus 6. That is cofactor. And here cofactor of 3 will be, it will be minus into minus plus, that is 4. Okay. Then it is that I find with minus 4. So this is minus 1 into minus 1 into 1. So this will be minus 3, 2. So that is the transpose. I change rows into column. So adjoint of A, in A into adjoint of A, that means matrix multiplication. This I have multiplied, that is rows into columns and rows into columns. Okay. So this will be ultimately this, that is minus 12, that is 24, and plus 12 minus 12 is 0. And again here plus 12 minus 12 is 0, and here minus 12 into minus 12. That is 24. That is minus 24. So I got this. Now I have to find out that determinant A into I is 1001. Determinant of A is 2, 3, minus 4, minus 6. Okay. So this will be determinant minus 12 minus 12 into minus, this is also minus 12. So 1001 I multiply with that. Okay. So similarly I can find adjoint of A is equal to adjoint of is equal to AI. I can prove also adjoint of A into A adjoint of A into A. This is determinant AI. So we will. This is little difficult in calculation. I am going to do one more sum after this. Okay. Now question 4. They have given you when A is this matrix, that is 3 minus 2, 7 minus 4. Show that A into adjoint A is equal to adjoint A into A is equal to determinant A is equal to unit matrix I. Okay. So adjoint A, when I find out that is the cofactors with the transpose. Cofactors, this is the cofactor with the transpose, that is minus 4, 2, minus 7, 3. Okay. So A into adjoint A, I multiply. When I multiply, I get minus 12 plus 14, minus 28 plus 28, minus 28 plus 28, and my 14 minus 12, that is 2002. Similarly, when I start with this adjoint A into A, then I get the final result is 2002. Determinant A into I, determinant A into I is the unit matrix, that is 1001. Okay, so determinant will be here. I'll calculate 3 4s are 12, that is minus 12, and this is minus plus 14. So this is 1001. So I am left out with 2. So I will multiply unit matrix with 2002. So we have shown that A into adjoint A is equal to adjoint A into A is equal to determinant A is equal to I. It is always the result is always true. Now next is that we can do with a bigger number, but that you try. Now next I will be telling you that inverse of a matrix. Okay. Determinant of a square matrix A, that is mod of A, that is determinant of A, if it is equal to 0, then we call it as a singular matrix. Singular matrix. And if it is not equal to 0, then we call a non-singular matrix. Okay. Now the inverse of the matrix we are going to study. We are going to study inverse of matrices. Inverse of matrices. A non-zero square matrix, always we will take a square matrix. a non-zero square matrix is called invertible if there exists another matrix B such that B of same order, they are of same order. Suppose it is 3 and B will be also order 3. Same order, then AB is equal to BA is equal to, if it is IN, that is unit matrix of order n, then B is called the inverse of matrix A. Inverse of matrix A, we denote it as A inverse. We denote it as A inverse. Therefore, always A into A inverse is equal to A inverse into A is equal to determinant A into I. It's okay. Now, sorry, is equal to I is equal to I means unit matrix. That means if the product of two matrices, the inverse and the matrix, it will give you a unit matrix. Now, A into adjoint A is equal to adjoint A into A, that is adjoint A into A is equal to determinant A into I of order n, then A inverse will be A into adjoint n divided by the determinant A is equal to adjoint A into A divided by determinant A, which is the formula for finding A inverse wherever determinant of A not equal to 0. That means it is a non-singular singular matrix. Non-singular means no answer, the determinant will be not 0. Okay, so I think all of you have understood it. Next time I am going to start that the sums of the inverse, how to find out the inverse.